Origin of the plan. The石門Reservoir was completed in 1964 and has been in operation for more than 50 years. It's the key water supply facility for the northern parts of Taiwan. The steep terrain and fragile geological formations of the石門Reservoir catchment are hard to resist typhoons and tend to release debris. It turns out that typhoons coming often cause high turbidity and great siltation, and eventually decreases the water supply ability of the石門Reservoir. In 2014, Typhoon Aili attacked Taiwan. It caused high turbidity and 28 million cubic meter of siltation to the石門Reservoir. We had no choice but to stop the water supply for 18 days. To save the石門Reservoir, our government has been working on the plan, improvement of the石門Reservoir and its water catchment area since 2006. In addition to conserving upstream catchment and improving downstream tap water system, the石門Reservoir has been under great reformations, including the hydraulic desilting tube, modified by power generation tube, multi-level intake, and Zhongzhuang Lake, etc. Although the above reformations have overcome the water turbidity issue, they are not suitable for the siltation issue. In order to perfectly remedy the siltation problem of the石門Reservoir, the authorities have planned two desilting tunnels, Amuping Desilting Tunnel and Dawanping Desilting Tunnel. Considering that the existing hydraulic desilting tube in the石門Reservoir is capable of dealing with the muddy flow and the tunnel construction may have side effects on the reservoir operation, our government decided to construct Amuping Desilting Tunnel first. The Amuping Desilting Plan was approved by the Executive Yuan in September of 2014, with a total construction budget of 4.6 billion NT dollars. The Amuping Desilting Plan was incorporated into the Water Environment Construction of Prospective Infrastructure Construction Plan in July of 2017. The budget of Amuping Desilting Tunnel is 3.7 billion NT dollars. It is a turnkey project and was started in November of 2017. The project is scheduled to be completed in 2021. Design concept. Amuping Desilting Tunnel and Dawanping Desilting Tunnel are designed for different silt transport characters. Affected by reservoir impoundment, when the muddy sand from the upstream channel of the reservoir enters the reservoir storage area, due to the sudden decrease of flow rate, the coarse particles will gradually fall and become sediments, and the fine particles will form the density current and sneak into the bottom of the reservoir to continue to flow downward. If the density current has nowhere to go, it will be turned upside down to form a muddy water pool, and finally it will fall into the reservoir storage area. To remove the sediment in the reservoir, the appropriate location for treating larger sand particles is the delta at the upper stream of the water catchment area. As for the density current of extremely fine sand particles, those particles can be drained away hydraulically through the bottom drip hole of the dam. Dawanping Desilting Tunnel is close to the dam and is a good place to discharge density current. Using the water brought by hitting typhoon to carry out hydraulic dredging, the tunnel can reduce the accumulation of fine particles and prevent the formation of muddy water to affect the water supply. But it can only be used during typhoons and flood seasons. In addition, the sediment that has fallen to the bottom of the catchment will not be taken away. Amuping Desilting Tunnel at the upper stream is closer to the siltation delta. The main desilting way is boat dredging. The silts at the river bottom, regardless of coarse or fine particles, are dredged and temporarily stored in the sluicing pool at the tunnel outlet, which will be flooded away during the typhoon season. The function of the Amuping Desilting Tunnel and Dawanping Desilting Tunnel complete each other. Construction works. There are four major portions in Amuping Desilting Tunnel construction: intake, main tunnel, outlet and sluicing pool, silt classification, total 4 facilities. 1. Intake. The tunnel is located about 1 kilometer from the downstream of Amuping Tourist Boat Pier, including adit, water intake, tunnel entrance, etc. As the main tunnel pre-construction project, the adit is located on the right side of the tunnel entrance and is about 306 meters long. It is the earliest construction of the main tunnel. The intake elevation of the adit is 245 meters, higher than that of the main tunnel intake of 235 meters. The higher adit portal elevation reduces the chance of water intrusion and is beneficial to the construction of the main tunnel. The adit has a D-shaped cross-section that is 8 meters wide and 7 meters high, the same as the main tunnel. 4 sludge pipes are hung on the top of the adit. Once the adit is completed, a swing-type sluice gate will be placed at the intersection between main tunnel and the adit. The gate is normally closed to prevent water from flowing into the adit. The breaking of the adit began in July 2018, and the adit was connected to the main tunnel in December of the same year. The intake is located next to Amuping platform, 80 meters from the tunnel entrance, about 220 meters from the reservoir bottom. The intake is a sluice gate controlled spillage weir with an elevation of 235 meters. The elevation of the tunnel entrance is 230 meters. 3 sluice gates in arc shape with a width of 6.5 meters and height of 5.3 meters are located at the intake, which are often closed and will be opened for desilting or flood discharge during typhoon and flooding season. 2. Main tunnel. The total length of main tunnel is about 3,702 meters. The intake elevation is 230 meters. The outlet elevation is 115 meters. The slope is about 1 of 32, and the design flow volume is 600 cubic meters per second. The main tunnel has a D-shaped cross-section that is 8 meters wide and 7 meters high. A total of 4 sludge pipes are set on the roof of the main tunnel from the connecting of the adit. Adopting new Austrian tunnel method, NATM, the excavation length of each round depends on rock classification. The tunnel is to be built from both ends toward the center. Access to the entrance is through the adit before the breakthrough section, built by end of construction session. When a flood is discharged in the main tunnel, the maximum flow speed reaches 20 meters per second. High blast furnace slag concrete is used for tunnel lining to reduce abrasion and avoid micro cracks. During main tunnel excavation, movable inverted arc bridge is set behind excavation section. The excavation, steel rebar installation and lining concrete of inverted arc will be in progress simultaneously under the inverted arc bridge. Tunnel is to be lined with movable steel forming behind inverted arc works. Various construction works can be in progress simultaneously, without affecting construction vehicles moving in and out. The construction duration can thus be reduced. 3. Outlet and sluicing pool. The tunnel outlet is under a place nearby 35K along Thai No. 4 road. The sluicing pool is located at No. 10, No. 11, and No. 12 sediment pool of the石門Reservoir. This section covers outlet, sluicing pool, etc. The tunnel outlet is located at the embankment of Thai No. 4 road with a horizontal distance of 50 meters. 33 retaining group piles with 1.5 meter diameter are driven for embankment excavation. A 5-meter-long false tunnel is built for tunnel entry protection to ensure embankment safety of Thai No. 4 road during outlet construction. The total length of sluicing pool is 621.3 meters. The width of the pool is 8 meters to 76 meters. There are 3 sinks in sluicing pool. The main function is storing the fine particle silt after sieving from the silt dredged by the dredging boat at the intake. The stored silt is to be flooded into sea via Dahan River in typhoon season. Sluicing pool is composed of gradient section, pool section, and sluice gate pier section. The width of gradient section changes from 8 meters to 62 meters. Pool section is composed of 3 rectangular flow channels with a width of 20 meters and stores about 200,000 cubic meters sieved fine particles. In order to improve desilting, 480 wall-mounted nozzles and 42 swing nozzles are installed inside the sluicing pool. Sluice gate pier is the last section of sluicing pool. 3 arc-shaped sluice gates with a width of 18 meters are installed. This width is the largest one among all sluice gates in Taiwan. The bottom elevation of sluice gate is 105 meters, 10 meters lower than that of tunnel outlet, EL 115 meters. Dahan River with bed elevation about 103 meters is right outside the sluice gate. The muddy water in sluicing pool can be drained away without a problem. The arc-shaped sluice gate is often closed to maintain the high water level of the sluicing pool. The silt of fine particles is kept wet and soft in order to be hydraulically flushed away during typhoon season when sluice gate is opened. 4. Silt Classification Facility. Silt Classification Facility is located to the left of sluicing pool, with an area of about 1 hectare. The silt dredged by dredging boats at tunnel intake is transported through sludge pipes to Silt Classification Facility. After coarse particles are sieved out, silt of fine particle is sent back to sluicing pool. The water heads of sludge pipe between adit original and tunnel outlet differs more than 100 meters. A silt classification facility is installed with this waterhead difference to lower energy consumption and raise silt classification efficiency. Silt classification facility is composed mainly of buffer sink, vibration sieve, sand washing machine, silt and sand segregation machine, transfer sink, etc. Based on the size after sieving, the particles are classified as gravel, coarse sand, and fine sand for stockpiling. Conclusion. To extend the service life of石门Reservoir, Amuping Desilting Tunnel is the most important plan of the石门Reservoir reformations. It is the key facility to maintain the storage capacity and the water supplyability of石门Reservoir. The tunnel has distinctive functions of reservoir siltation reduction, soil and sand resource recycle, and flood prevention. In the near future, Amuping Desilting Tunnel, Dawanping Desilting Tunnel, and the hydraulic desilting tube, modified by power generation tube, will work together to deal with the siltation issue of the石门Reservoir.